Hello guys, welcome back to our channel again. Today we will solve the 19th question of June Lead Code Challenge. So the question is longest duplicate substring. What we have to do is we have given a string and we have to find a duplicate substring in the string. Suppose let's consider the example BANA. So in this, if we find the substring, we have first duplicate substring as A. A we find two times, first here then here. So A can be the answer. AN and then again AN. So here we have AN, here we have AN. So we have this also a possibility. So before we found A and A, but its size is 1. But in this case the size is 2. So we'll take this. Now we try to find something else. Now we will try to find out for 3. So in 3 we get A. So for 3 we have for 3 we have ANA and ANA. So this is also true. So till now our answer is 3. Now we'll try to find more bigger substring. So here the length is 3. Now we'll try to find out for 4. So if we take B, A and A, no, there does not have any B, so it can't be there. A and A and, so if we take this as a string, then we does not have any answer till now. So for this there is no answer for an A and A, so we does not have any answer. So for the final answer what we get answer as 3. So this is our answer. So what we have to do, we have to find out the longest duplicate substring in the array or in the string. So now let's understand the approach using this example. So first of all, what we have to do, we have to choose a number which represents the length of subset or substring. Now suppose we will start iterating from 1. So let's consider the length equals to 1. So first of all, what we will choose a starting letter B. Then this is our first substring as B. Now we will choose A. So it is not equals to B. Then we will choose again N. So it is not also equals to B. Then again A. Then N. Then A. So all the substring is not equals to B. Then we will choose A. Here it will come N. So N is not equals to A. So here comes A. So A is equals to A. So now we found A equals to A. So what we will do? We will increment this. So after incrementing, it will become 2. Now what we will do? We will find first substring. So it will be BA. Then the second substring will be AN. So AN is not equals to BA. Then what will be the next string? NA. It is also not equals. Then AN. Then NA. So all the strings are not equals to this. Now what we will do this with second one, AN. Then we will compare it with NA, so it is not equals. Then when we will compare with AN, so it is equal. So first of all, we will make it true. So after becoming it true, it will be incremented. Then again the substring will be formed BAN and ANA. So BAN is not equals to ANA. Then we will find out second substring, it will be NAN. So it is also not equals. Then ANA. So it is also not equal. Then we will find the second substring, it will be ANA. And then here it will come NAN. So it is also not equal. Then we will do ANA. So this is equal. Now we will again increment this. This will be a 4. And our first substring will be BANA. Now our second substring will be ANAN. So it is not equal. Now next what we will do, we will again increment this, so it will be NANA. Now after this what will happen, here it will be ANAN and here it will be NANA. So it is also not equals. Then next substring will be NANA. So no next substring will be there. so we will not compare. So for 4 we does not found any substring which is equals to each other. So what we will do, we will consider 3 as a solution. So for this we have 3 as a solution. Now we all know that we have how we have to solve the question. So what are the requirements? First is the length. So first of all we have to find the length, that which substring can be fitted, or how much length of the substring will be there. So first of all we have to find out the length. Second we have to find substrings. Second we have to find the substrings and then the compare. So for finding the length, what we will use? We will use binary search. So for making substring, what we will use? We will use hashing. And for comparing, what we will do? We will use Rabin Krap method or Rabin Krap algorithm. So we have to discuss 3 things in this question, which is binary search, hashing, and Rabin Krap. So first of all we will discuss binary search. So for binary search we all know that we require 3 things: left, right, and mid. So left will point the least number of elements exist in the substring, whereas what right will point? Right will point the highest number, which will be length of this string minus 1, and mid will point left plus right divided by 2. Now in this case we will use some other formula for calculating the mid. It is also very efficient. It will be L plus R minus L. Now what is the difference between both the formulas? There is no difference, but I prefer to use this one. So if we calculate using both, suppose let's consider L equals to 10 and R equals to 20. So with the first formula, with L plus R divided by 2, what it will be? It will be 30 divided by 2 equals to 15. With this formula it will be 20 minus 10 divided by 2, it will be 10. Sorry, 20 minus 10, it will be 10. Divided by 2, it will be 5. So 5 plus 10 plus 5, it will be 15. So answer is coming same, but for string comparison it is best formula which is used. Now this is the binary search part which we are going to use in this code. Now second we will discuss hashing, that how using hashing we will calculate a substring. So now we will discuss hashing. So what is hashing? Hashing is a method to make substrings. So in this case what hashing do? Hashing converts a substring or a string into an integer, and then that integer can easily be compared. So in this part we will look at how we can make a string a integer with the help of hashing. So first of all we will take an as a example. So for hashing you need 2 things. First, a prime number, which can be any prime number, but in this case I am using 3 for easy calculation. And the second thing, you all should know the ASCII values of A to Z, that will start from 97. So in this case I am not taking that ASCII values, I am considering it to be 1. B should be equals to 2, and till Z will be equals to 26. So we are using this as a notation. So we require 2 things. First is a prime number and second is a character notations. Now what we will do, we will multiply each index of the string with the prime's power. Means what we are doing, we will multiply A multiply by 3 to the power 0. Now in this we will replace all the a and b by their respective values. So b will be replaced by 2, a will be replaced by 1, we will again replace by 2, and a will be replaced by 1. So this will be our answer which we will calculate. So in this case what it will be, so in this case it will be 70. So this 70 is the integer representation of AB. So now if we find the integer representation of an, what it will be, the integer representation will be this. So now we all know that how we have to find the hashing value for any string. Now we will discuss Rabin Krap method. Now let's understand the Rabin Krap method. So for understanding what we will do, we will take this as an example and then we will do. So now let's understand the Rabin Krap method. So for understanding, we will take this as an example. So let's first consider the length of substring. So let's take it equals to 4. So our length of the substring will be 4. Now we have to first consider the first substring. Let it be BA and A. So if we will found the integer value, now if we find the integer value of BA and A, what it will be? So for that, first we have to consider a prime number. So it will be 3. Next thing, what we have to consider? We have to consider A, B, C till ZZ. We have to consider all the values. So we will consider it to be 1, 2, 3 till 26. So these two things we have declared. Now we have to find out the hashing value. So what it will be? It will be B. So it will be 2 multiplied by 1 plus 1 multiplied by 3 plus 14 multiplied by. So the hashing value for BA and A will be 158 after the calculation. Now we have found the value for BA and A. Now we have to find it for BA and A N. Now what it will be? It will be, what will be the hashing value for A and AN? It will be 430 by this calculation. Now for every time we have to calculate these 4 values. So for making our work easy, we have Rabin Krap method. Now what it will do? So we have found this value. So what we will do? We will decrease the first index value which we have before. So what we have B before. So we will decrease this value. So 158 minus 2. So what it will be? It will be 156. Now we will divide this value by 3. So what it will be? It will be 52. And then what we will do? We will plus the last value of this new substring. So what it will be? It will be 14, and we will multiply it with the 3 to the power the length of this. So what it will be? It will be 4, it will be 3. So what it will be coming? It will be coming, so it will be 378. So it will be equals to 430. So we have one more formula. So for that, what we have to do? We have to first subtract this 158 from the first value. So what it will be? It will be 158 minus 2. So it will be 158 minus 2 equals to 156. Then we have to divide with the prime number. So it will be 52. And then we have to add this last value, which will be 14 multiplied by 27. So how we will find this 27? We all know that we will first calculate this 14 multiplied by 3 to the power something. So what will be 3 to the power? So in this it will be 3. It will be the length of this substring minus 1. So in this case it will be 3. So it will be coming 578. So 378. So for the sum it will be 430. Now we will see that why these two values are coming to be same. So what basically we are doing is, first of all we are subtracting this value. So after subtracting, what it will be looking like this. Now what we are doing, we are dividing this value. So we are dividing this value by 3. So here it will be 1, here it will be 3, and here it will be 9. And then what we are doing, then we are adding 14 multiplied by 2 to the power 3, it will be 27. So ultimately what it is doing, it is converting this to this without using more steps. So we will use this Rabin Krap method for making the substrings values. Now we will see my code and then we will understand that what I am doing. Now let's understand the code. So first of all, here I have declared a vector power which will store the values of powers which we are calculating. Suppose 3 to the power 0, 3 to the power 1. For longer substring also it will calculate. Suppose we have a string of length 1000, then we does not require to always calculate 3 to the power 1000 or 3 to the power 100. It will be a very lengthy work. So for that I am storing, or I am creating this power function or power. So for that I am making this power variable or power vector which will store that values. And second, I am considering a prime number. It should be very high, because if we use lower values or lower prime numbers, then it will produce TLE or time limit exceeded error will be there. So this is our main part which we are going to do. So first of all, I am resizing the power according to my string. So suppose the string have length 10 or 100, then we have to resize it to 100 only. Then we are initializing power 0 index by 1, because 3 to the power or anyone's power 0, it will be 1. Then what we are doing, then we are calculating the powers indexes. So why we are dividing it by prime? Because of our less space or less memory. We are taking modulus with a prime so that we get smaller values, do not have higher values. Now here I have start doing binary search part from here to here. Now first of all, what I have initialized L, I have initialized R. Here I have initialized the answer. Means it is the breaking condition of the binary search. It will be length. If length becomes greater than R, then it will be breaked. Now we will calculate the mid with the help of second formula, which is L plus R minus L divided by 2. Now we will find out the using Rabin Krap method that we have this substring exist in this string or not. So we will look at this function later. So first of all, what we will look, if this returns a string and its length is greater than 1, then we will check that if the length is greater than answer or not. If it is greater, then we will go further, and then we will change answer equals to valid. Means we will change the answer by current answer. Then we will do the standard binary part, that we have to increase the left by mid plus 1, and if we does not found any such value, then we will decrement our highest value. Now we will look at our main part, which is Rabin Krap method. Now before seeing the solution of Rabin Krap method or Rabin Krap function, what we will do, we will first understand that how we will solve using all these three parts. First is binary search, second is hashing, and third is Rabin Krap. So for this we will make a map in which at the hash index, means at hash index we will store the starting index of that value. Means if we found some substring, then we will store this value, and then what we will check that if some value match, means if some hash match with this hash, then we will check that this I shouldn't be matched with the current I or the current starting index. If they does not match, then we will return this as a answer for that length. So now we will see the Rabin Krap method, that what it is. So now what we will see, so now we will see the function of Rabin Krap. So this is our Rabin Krap function, in which we are taking two things as an input. First is a string s, and second is a integer k, which will store the mid. So first of all, we are checking that if k is equals to 0, if it is equals to 0, then we will return an empty string, because for len 0 we have only one possible substring, which will be empty string. Now after that, what we will declare, we will declare a hash int, which will store the hash value. Now after this, we will consider a map, an ordered map, in which first will be index and second will be a vector int. So index will store the hash value, and this vector will store the starting indexes of all the possible hash values with this. So after this, we will make, or we will find the hash for the first substring of particular given length. If this is given, then we have to suppose find the substring of length 4. Then in first this for loop, what we are finding the hash value for BANA. For this we are finding the first. Then this first loop, what it is doing, that we all know that what this first loop is doing, it is finding the first possible substring of given length. So we will raise it. Now here what we are initializing I and j. So what it will be, I will be the starting index of the substring, and k will be the ending or the final index of the substring. Now what we will do, we will append that hash value or that map. Now this will append the hash value of map, and it will be initialized with 0, because it is starting with the 0th index. Now what this while loop is doing, it's letting all the possible combinations. So how many possible combination is there for any number of substrings? Now if we run for BANA, so suppose the mid or the length of the substring is 4. Now how many possible combinations can be there? It will be calculated by this. Now what we are doing here, first of all, the first part of calculating the next value, which is the subtraction part, is done by this hash first line. And this, what it is doing, it is just multiplying the values with 101 and calculating the prime value. Now what this is doing, this is doing the last step of Rabin Krap, which is just adding the last index multiplied by the prime value. It is doing that thing. Now after this, what I'm doing here I am just checking that if the find index, means the hash value which we have found, is already in their map or not. If it is there in the map, then what we will do, we will find that the string which we are currently checking and the string which is stored in the hash is same or not. If it is same, then we will return that substring. Else what we will do, we will push back that value into hash map, the starting index of that. And if it does not exist that hash value only, then we will increment, or then we will initialize the map with the hash value, and then we will initialize its vector by the value itself. Thank you guys. For more such content, like, share, comment, and don't forget to subscribe.